Hello students, as a part of our understanding over the CDMA 2000 system, IS95 and CDMA 2000 system and the specs, this is the second part of the discussion where we will start with the error correcting coding. In the last module we have discussed up to the variable rate speech coders, and here we will start with the error correction coding. So, we understood that basically two different kind of the coding schemes are involved in an IS95 transceiver, and in the transmitter side we utilize the speech coder as well as the error correcting coders. And speech coders are basically to modulate to code the signals, to code the speech signal, and error correcting codes are deployed to correct or to take care of the deep fades of the wireless communication channel. Let us see how many different kind of the error correcting codes are involved. We understand that there are two different code rates, two different rate of the speech communication. One is 8.6 kbps, another is 13.3. We have also uplink and downlink communication. So, we will see that the error correcting codes are fourfold here. For 8.6 uplink, 13.3 uplink, 8.6 downlink and 13.3 downlink. And remember the after coding we provide the interleaving interleaving actually, and only the corrected codes are not released in the air. To get the maximum code gain, the interleavers should be accompanied with the error correcting codes. And here we have seen that we have two different kind of the vocoders, the voice coders. One is IS96A, and then it was first developed, and the latest one was the enhanced variable rate coders, which can support the 8.6 kilobit per second as well as 13.3 kbps. And for 8.6 kbps, now we will first discuss about the error control coding, for which we understand that we have IS96A vocoder as well as EVRC coder. 8.6 kbps is basically defines the rate set 1, and hence it will have the following steps for the encoding mechanism. Encoding process here starts with 172 bits. So, it takes 172 bits because it corresponds to 20 milliseconds frame duration from the vocoder, and in the next step he adds a 12 length frame quality indicated bits, and these bits are basically to check you whether the frame is properly received, or the frame is good or frame is bad, whether the further processing on this frame should be done or not, and it is received correctly or not, that also will be an indication given by the FQI. And after this 12 bit FQI, we add 8 bit encoder tail bits, so the total number 172 plus 12 plus 8 turns to be 192 bits per frame, and these bits are then encoded with rate 13 convolution encoder and with a constant length of 9. So, we need the generator polynomials for this encoding, and these are the three generator polynomials defined in the spec for generation of this encoder, 1/3 convolution encoder. And once encoded, this, as it is a 1/3 convolution code, and after this encoding process you will be reaching a bit rate up to 28.8 kilobit per second. And once this is done, then let us see for the uplink. So, we discussed about the 8.6 kilobit per second in the uplink. In that case, how error correcting codes are done. Now, this is 13.3 kbps in the uplink. So, encoding process is not same, because we do not want the fundamental modulation and the data rate coding modulation rate to be changed, modulated data bit to be changed. So, to get a different speed, a different data rate for the coding for this speech transmission in the uplink, we cannot actually incorporate the same kind of the error correction codes. So, for 13.3 we need to proceed with a different coder also. Here we proceed with the CDG13 coder, and we start with the 267 number of the bits. So, number of the bits supportable in the for higher communication is also high, and that's also corresponds to 20 milliseconds frame size. And we add frame eraser bit after this. Then the similar to the earlier case, 12 FQI, I mean frame quality indicator bits are there to detect whether the frame is received good situation or a bad situation. You add 8-bit tail to help the bit decoder, and finally you are ended up with the 20 milliseconds frame with the number of the bits equal to 288. And for this we in uplink for the high data rate, we proceed with the half convolution code rate in the encoder, and the constant length is same. And these are the generator polynomials. Two generator polynomials are involved for the uplink 13.3 kbps. Let us see about the downlink. For 8.6 downlink, error correcting codes will be somewhat different. It uses the same combination of these FQI bits and the tail bits to indicate whether the frame is received correctly or not, and to help the BTRB decoder in the receiver. But it uses a rate half convolution encoder instead of 1/3 convolution encoder to bring the data rate up to 19.2 instead of 28.8 that we have seen earlier. And so your generator polynomials needs to be different, because that needs to be corresponding to the 19.2 kbps. So these are the two generating polynomials involved for this 8.6 kbps downlink. The error correction coding that we are now using for the 13.3 kbps downlink, let us see. This mode uses the same encoding steps at 13.3 kbps uplink, but it leads to 28.8 kbps rate if I truly follow the uplink procedure, while only 19.2 kbps is the maximum capacity for the downlink transmitted frame in the traffic channel. So what we do here is, in 13.3 kbps downlink, we first generate exactly by following the process of 13.3 kbps uplink that leads us to 28.8 kbps data rate, and then we use a puncturing. Puncturing means actually some of the bits in between forcefully you turn down to be 0, and you put zeros. That zeros actually reduce the data rate. Basically it is equivalent to be, or interpreted can be to be an encoding of the vocoder signal output as a rate of 3/4 convolution code. So either you go ahead with a 3/4 convolution code, but we don't do that. We go ahead with a puncturing, and every 6 here actually eliminates the third and the fifth bit of every 6-bit symbol repetition block. And this basically the way we do is as the 2 bits we try to eliminate, that is created by the generator polynomial 2, and all the bits from the generator polynomial 1 is kept intact. As I told that to get the maximum profit or maximum gain out of this gain from this encoding process, we have to use the interleavers. And so the output of the convolution coders we feed inside interleaving, which basically is a block interleaver, and which is having a length of 576 for at set 2, which is at set 2. 13.3 kbps set is a at set 2. Interleaver is basically a matrix which randomizes the encoded output, and here we use a matrix of 32 cross 18, and data are written in the line filling the first column, and then the second column, then the third column, and then so read out, and they are read out orthogonally one by one. So let us see actually if I do the encoding, but you don't provide any interleaving, where the bit error probability can be, and how much do we save if we provide interleaving or randomize the output. See the bit error probability, suppose for 10 to the power minus 4, here the plot is plotted for rate 1/3 repetition code, and over a flat Rayleigh fading channel for this IS95 system. We can see that for 10 to the power minus 4 bit error rate, without interleaving you need to provide an SNR, which is expressed in dB. We need to provide an SNR around 42 dB, and whereas with interleaving you can come down with a 28 dB kind of. So the huge saving more than your 15, close to the 13 or 14 dB because of the interleaving and randomization provided by interleaving. Now that's about your channel coding. Let us revisit the spreading and modulation. We understand that there are several tasks needs to be provided for several kind of the signal needs to be transmitted, several data rate needs to be supported. So, spreading code can never be same for all this. And IS95 is basically using three different kind of the spreading codes. One is a long spreading code, short code, and the Walsh code. Let us first see what about the Walsh code. What is a typical Walsh code they use. Walsh code, we understand that Walsh code can be generated by the Hadamard matrices repeated from the n plus 1th order of Walsh-Hadamard code can be generated from the nth Hadamard matrices written in this way, arranged in this way, where this H bar is nothing but the modulo 2 complement of this matrix H. And here the recursive relation, this we start with Hadamard matrix 1, where the values are initialized like this, shown in equation 1.6. And the Walsh code of IS95 that will be the code by this. Actually, if we first generate the Walsh-Hadamard code 6, then all the columns of this Walsh-Hadamard code 6 are the Walsh codes that are used for spreading the traffic channel in the IS95. Short spreading codes are basically of the PN sequence codes of length 15, and they are generated by the linear feedback shift registers, the way and the process that we have learned already. And remember, we add a single 0 in the sequence to increase the periodicity to 2 to the power 15, not to 2 to the power 15 minus 1. To increase it to 2 to the power 15, we add a sequence of zeros also, and which corresponds to totally 26.7 milliseconds for the transmission. These are the two generator polynomials or the generator sequences, generator polynomial to generate this PN sequence of length 15. The long spreading codes, they are also the PN sequences only. So, PN sequence of length 15 generates a short code. Here we will see the PN sequence of length 42 will generate the long spreading codes. Here we do not add a sequence of 0 like the short spreading codes, and finally we end up with a coding length of 2 to the power periodicity of 2 to the power 42 minus 1, which actually finally equivalent to 40 days. The generator polynomial for the same will be like this, and the output of this shift register is then modulo 2 added with the long code mask. So, here there is a concept of mask, and this mask can be generated from the electronic serial number, or it can be also generated from the encryption algorithm provided. We call it a private mask or the public mask, based on where you are generating the mask. And but this key part is that this long code mask is different for the different channels, and hence you can easily differentiate between the access channel and paging channel, and it can be also utilized for the BS identification, access channel numbering, and it can be also utilized for the different kind of the synchronization paging channels and the traffic channels. Based on the type of the use that you are trying to utilize, we go ahead with that. So, now this is the time to understand what are the different logical and physical channels exist in IS95 system. We will start with traffic channels, because traffic channels are the channels who carry mainly the voice data, and for each this is the most important communication requirement for IS95, and there are two possible data set also required to be supported over the traffic channel. We understand one is the rate set 1, another is the rate set 2. See the limits of the rate set 1. Rate set 1 should have support the data rate starting from 1.2 kbps to 9.6, whereas your rate set 2 should support from 1.8 to 14.4. And these are the source data rate we understand from the output of the vocoder, and they are possibly repeated. So, they are conventionally encoded, they are interleaved, and they are spread, then they are modulated, and spreading modulating operations will be different from the downlink as well as the uplink. And the control messages that are also transmitted on the traffic channel along with the voice data transmission, they are like this. For uplink, actually the control channel information that we send is the power measurement report, which is used for the power control in the downlink, pilot strength measurement, handoff completion, long code transition request, long code transition response, data burst, and the request for the analog services. These are all the important information, the traffic channel information control messages that also flows through the traffic channel of IS95. For downlink, such control messages will be the neighboring list, the pilot measurement request, handoff direction, long code transition, long code response, data burst, as well as your analog handoff direction. So, this was about the traffic channel. Next comes the access channel. It is the channel that in the uplink direction, which is used for signaling by the mobile stations without a current call. So, it is something before setting up a call, how this signaling will be exchanged between the mobile station and the base station. The channel that is responsible for that will be the access channel, and he includes the information messages, for example, the security message, BS challenge, authentication challenge response, all those, the page response, the origination, the registration information, everything. The access channel, they uses the source data of 4.8 kbps. So, they also use the spreading and modulation, very similar like the uplink traffic channel mode, but remember there is no gating done here, and all the repeated symbols are actually transmitted. And since the access channel is also spread with a long spreading code, and considerable number of the access channels can exist. In fact, this access channel that we get here is around 32 numbers per paging channel. A mobile station can randomly choose any one of these access channel for the start of this transmission, for start of his paging, I should say. And the call initiated by this mobile station, it starts with a message on the access channel itself. Then the mobile station sets the initial power according to the received signal power measured and by his open loop power control, and he transmits a probe. If this probe may be actually the request to connect, or we call it the address request, and then once actually the request is done, is acknowledged before the timeout, and then the access will be successful, and this acknowledgement is required to come from the base station to the mobile. And this process is repeated if the access is not successful and till the probe is reached the maximum admissible power. So, slowly actually we start increasing the power of the probe also in the successive attempt, so that at least with one such a certain power level of the transmission, the acknowledgement should happen. Next comes the pilot channels. What are the information that the pilot channels carry? Pilot channels allows the mobile station to acquire the timing information of the base station for a specific base station. It also obtains the transfer function from the base station to mobile station. It tries to estimate the signal strength of all the base stations who are surrounding the who are there in the environment, who may be the interest of this mobile station, close to this mobile station, and that may play a very important role when during the handoff. And pilot channel, it is very much similar to the downlink traffic channel, but it has some peculiar properties. Number one, it is not power controlled, because reason is you don't know what's the location of the mobile station, and this is a pilot that you are sending from the transmitter to the receiver. So, it should be used by lot of the mobile station. You cannot do any power control, and we transmit, preferably you transmit with a very high power level, so that none of the mobile stations in the network misses this control information. This guy uses this pilot channels, they use the Walsh code of 0 for the transmission. This Walsh code 0 means all 0 sequence, and with a very high transmit power, once it is transmitted basically the high I told, but how much high is it is here is a measure. Typically the power may be 20% of the total base station power assigned to the pilot channel, and pilot channel is such that it could be easily demodulated because you are spreading this all 0 code with a short length spreading codes, and only difference between the pilot transmitted from the different base station will be what? There will be a temporal offset, and mobile station requires to acquire all the pilots coming from the different base stations, and from that extract the synchronization information about the network, and you align your timing information with any one of the base stations, your preferable base station where from you are receiving the maximum power. Next comes the synchronization channel. The synchronization channel, it transmits some certain information about the system details. So, it is very important that pilot channels are basically to extract the timing informations of the network, and this synchronization channel gives you the system details. It may be actually required for the mobile station to synchronize him with the whole network. What are those information? It may be the network identification information, the offset, the long code PN code offset between the mobile stations, between the base stations, the long code state, the GPS system time, local time and the difference of the local time with the GPS, and rate at which the paging channels operate. And as it is a very vital information, so we try to transmit it at a very low data rate, and hence it is transmitted at 1.2 kbps, and after convolution it is coded. So, after convolution encoding with the data rate of half and repetition, this synchronization data is transmitted over the synchronization channel. Remember, we never scramble this channel because no application of the long spreading long code mask is there on this channel, and each frame of this synchronization channel is aligned at the start of the PN sequence. Here comes the second category of the channel named as paging channel. It transmits system and call information from the base station to the mobile station. The call information means the start time of the call, end time of the call, quality of the call, and whether it was a priority call or it was a medium call kind of the call. So, all that actually needs to be transmitted through some channels, which is a paging channel, and several paging channels can exist in each of the cell, and each of them is a 9.6 kbps wide, 9.6 kbps supportable channel. So, the data rate maximum supportable by this paging channel is 9.6 kbps, and the information on the paging channel can include the lot of stuff. It can be the paging message to indicate the incoming call, the system information and the instructions. What is the system information? What is the handoff threshold? The maximum number of unsuccessful access attempt, list of surrounding cell PN offsets, the channel assignment message. So, once you have such data rate, such kind of the information data bank from your measurements you have done in the earlier time bin, so that information you can now actually broadcast via the paging channel, so that it will help newly joined mobile users, the mobile users who have newly joined the network to align himself and extract lot of the network related information will be revealed to him. And it also sends the acknowledgements to the access requests. After that comes the power control subchannel. So, power control is a very important phenomena for a CDMA network, we have understood, and to accomplish that operation, we understand that in the CDMA IS95 mainly it uses both the closed loop as well as the open loop, and for that, if it is a closed loop, then you need an inner loop and as well as outer loop to run. For that, every moment you need to send a feedback information from base station to mobile station, and to do that you need a dedicated channel for it. The dedicated channel name is the power channel, power control subchannel, and this power control subchannel is very important, and they are actually responsible to compensate the effect of small scale fading. Here SSF stands for the small scale fading. And in order to do the efficient control, the IS95 divides the signals in a small group we call the power control groups, and each power control group is having a width of 1.25 millisecond duration. So, base station will estimate the instantaneous signal to noise ratio for each user for each power control group, and it then sends a power control command to the mobile station within 2 power control groups, and the mobile station reacts to within 500 microsecond. So, this command signifies either an increase or some decrease of the SNR value, and basically increase, whatever it is, increase or decrease, it should be at the step of 1 dB in IS95, and the data rate at which we transmit all this feedback information and the command information, that will be at the rate of 800 bit per second. We do not wish to lose any command or any instruction, that is why the data rate is so low, and so that reliable communication is possible. The power control sub channel is inserted into the traffic channel by simply replacing them, some of the traffic channel replacing some of the traffic channel data symbols. And remember, your PCG, the power control group, it contains the 24 modulation symbols, and only first 16 are candidates for the replacement. The exact location, this is determined by the long code mask. It bits 20 to 23 of the long code mask in the previous PCG determined that which bit is to be replaced. That is all about the power control sub channel. And then finally comes the mapping of these logical channels to the physical channels. All that we have done is they are the logical channels. So, in order to map them in the physical channel in the downlink, mapping is done rather straightforward way. The different channels are assigned the different amount of the different kind of the Walsh code for spreading. So, you can identify the different channels by means of the Walsh code associated to them. Especially the codes, here are some examples, the codes that we use. We use the Walsh code 0 for the pilot channels that we have already discussed. We use Walsh code 1 through Walsh code 7, I mean Walsh code 1, Walsh code 2, 3, 4, 5, 6 and 7. All these are used for the paging channels. Synchronization channel uses Walsh code 32, and traffic channel uses any other Walsh codes available. So, in the uplink only the traffic channel and the access channels exist, and these are the assigned different long spreading codes, and are thus also mapped to different kind of the code channels in all the cases. So, but fundamentally the thing is that the way we will try to segregate the different channels in the practice in the receiver, that whether it is a signal related to the pilot channel or the paging channel or the synchronization channel or the traffic channel is coming up, some information definitely will come according to the Walsh code number, and some number will come in the frame format definitely, and using that actually that typical code Walsh code should be used to display the data to extract the signal correspondingly from the different kind of the channels involved. So, that is all about the CDMA 2000 preliminary understanding or some very basic understanding about the different kind of the coding techniques, the coders, voice coders as well as error control coders, the different kind of the modulation, spreading utilized, and also having the concept of the channels, the mapping of the logical channels and physical channels.